This is week 1, and we're now working on the distributive law. Now, the distributive law is something you actually learned in elementary school, and you probably really didn't think about it at the time. You didn't maybe know it was called the distributive law. For instance, if you were asked to multiply 3 times 42 in your head, you might have done it this way. You might have broken 42 into 2 pieces, 40 and 2, and then multiplied the 3 by each separately, and then added the 2 results. That would look something like this. Break the 42 into 2 pieces, 2 plus 40, and we're doing 3 times that number, 3 times 42, but you can times the 3 by the 2 to get 6, and you can times the 3 by the 40 to get 120, add those two together, and you have the same answer that you'd get if you did long multiplication with 3 times 42. 3 times 2 is 6, 4 times 3 is 12, write down the 1 and the 2. This is easier to do in your head. So what we did here, breaking the number into 2 pieces, we're multiplying a number by those 2 pieces by multiplying it by each piece separately and then adding them together. That's the distributive law, and in general it looks like this. We've got 2 pieces or 2 terms, or more, sometimes more, and outside we have a number that wants to get multiplied by that sum. So what we do is we like to draw arrows to remind ourselves that A wants to multiply B by B, and A also wants to multiply by C, and we're going to add that result. The distributive law also works backwards. If you have 2 numbers that have a common factor, you can pull that factor out, put it in front of a pair of parentheses, and put the 2 leftover pieces inside. We'll talk about that when we get to factoring on the next page. I have 4 examples. If I forget to give you time to write them down, please stop the video and write them down before we begin each one. So this first example is very simple. Here's my A, it's the 4. Here's my B, it's the X, and here's my C, it's the 7. So I'm going to multiply A times B, or in this case, the 4 times the X, and I'm going to write down the answer. Boom, boom. Then I'm going to write my plus sign, which is in between them, my plus sign. Then I'm going to do the 4 times the 7. So again, I like to draw arrows from the number outside the parentheses to each of the numbers or variables inside, and some people put a times sign above those arrows to remind themselves that it's multiplying, not adding. So 4 times x is simply 4x. Remember, there's an invisible multiplication sign here between them, and there's an invisible multiplication sign here between the 4 and the parentheses. Now I put the plus sign down, that's between the 2 terms, and I do 4 times 7, and I get 28, and I am done. And this will be useful for when we're simplifying expressions so we can begin solving equations later. Let's go to example 2. A little bit more going on here, but it's still the same idea. This term outside the parentheses, or factor, I guess you'd call it, wants to get multiplied by both things inside. It's like there's a new neighbor in town, and he wants to meet both people in the house next door. And when he meets with them, he multiplies with them. Take that however you would like. So I've got -5 times A times 2. Now I can only multiply the 2 numbers and then just bring the A along for the ride. So -5 times 2 is -10, and don't forget A, because he's also part of that product. Now here I have to be careful, because I'm going to be multiplying a -5 by what's going to turn out to act like a -3. -5 times a -3. Think of this minus sign now as making this number negative. So -5 times -3 is positive, because a negative times a negative is positive, 15. And then I've also got the A times the A. Don't forget that everybody here wants to multiply with everybody here. So I'm multiplying the numbers, then multiplying the letters. A times A is A to the 2nd power. And I am done because I cannot combine these 2 like terms. Likewise back here, I can't combine, these are unlike terms, and so are these, so we're done. Okay, let's take a look at example 3. And again, I forgot to give you time to write these down, so I hope you're pausing the video if you need the time. 3y to the 4th power, parentheses, or times, negative 2y squared plus 15, close your parentheses. Okay, so this whole clump, this whole factor outside the parentheses wants to get multiplied by this whole clump and this whole clump. Again, it's multiplication, so we're going to need to think about that as we work with these variables, so we do make sure we do the right things with the exponents. So 3y to the fourth power times negative 2y squared. I multiply the numbers. 3 times negative 2 is negative 6. I multiply y to the 4th times y squared. Remember, y to the 4th is y times y times y times y times y times y. That's y to the 6th power. Multiplying like bases, we add the exponents. So the exponents do change. Unlike when we were adding like terms in the last video, we aren't adding like terms, we are multiplying factors. So this is why the variable's exponent changes. Alright, next I'm going to put down my plus sign, and I've got a 3y to the 4th power times 15. So all I can do here is multiply the 3 by the 15 and bring the y to the 4th power along for the ride. 3 times 15 is 45, and we bring along the y to the 4th power because he's also part of the product. And this one is done. Alright, let's take a look at our last example. It is 6x outside the parentheses, and then inside we have x squared minus 2x plus 3, close your parentheses. Alright, my paper's getting a little bit crunched here, so I'm going to just draw my arrows underneath. 6x needs to get multiplied by 6x by x squared, and by minus 2x, and by 3. So this time the new guy in town wants to meet all 3 neighbors in this house. There's 3 neighbors in this house. So let's start with 6x times x squared. So there's no number here, so we'll just write down the 6. But the x, and remember that's x to the 1st power, times x squared. So x times x, or 1 plus 2, is x to the 3rd power. Alright, now I'm going to put down the minus sign, because it's going to be like a positive times a negative, so it will be minus. And 6 times 2 is 12, and x times x is x to the 2nd power. Remember, you are multiplying. This is why the exponents change. And finally, I put down this plus sign because it's going to be a positive times a positive. And we write 6 times 3 is 18, and bring this x along for the ride as part of the product. And we are done. In each of these answers, we are finished because there are no like terms to combine. If you get done with the multiplying and you have some like terms, make sure you combine them. Alright, that's it.